All right, Math 2, here we go, kids. We got lesson 7.1.3, two-column proofs. So we're going to learn about a different way to write a proof instead of the flowchart proof. And then our goal is to finish this before my lights turn off because I haven't been moving around enough. So let's see if we can do that today. All right, so here we've got a proof that we're going to do to prove that A is congruent to C. We want to prove that in a parallelogram, the opposite angles are congruent. So this is a two-column proof. We got statements and we got reasons. The statements, like in a flowchart, that's what you would put in those circles. And then the reason, that's the thing that you would put, below the circle to say why you're allowed to do it. What is left off of a two-column proof is we don't have the arrows saying what's happening next. I think this is a more kind of advanced version. I like the way it looks. It doesn't take up as much room. I like this a lot better. Anyways, so here's our first statement. We're always going to start off with something that we're given. We're given that TUVW is a parallelogram. So that reason is it was given to us. Now, because that's a parallelogram, we know that parallelograms, the opposite sides are parallel. So here it says definition of parallelogram. So we want to fill in the statement that's missing. Well, we know that since it's a parallelogram, TW is parallel to UV, because that's the definition of a parallelogram. It has opposite sides that are parallel. So we're going to write TW is parallel to UV. Okay, the other thing that I know is that TU is parallel to WV. So this side here is parallel to this side there. And that's also because of the definition of a parallelogram. So because it's a parallelogram, we know two things about this shape. The opposite sides are parallel. Now, since the opposite sides are parallel, all those angle pair relationships become true now. So for instance, they're saying that B is equal to C. Let's see where B and C are. B and C are here. And if we're looking at these two parallel lines, B and C are corresponding angles. So they have to be congruent because the lines are parallel. So we would say corresponding angles are congruent. Now your book plays a little bit loosely with proofs. Technically, corresponding angles are congruent, and here we're saying they're equal. So your book just kind of, it's just loose. It's a little bit lazy with the proofs. It cuts down on the number of steps, which is kind of helpful sometimes. So they're just going to, instead of say that these two angles are congruent, they're going to say they're equal, which they kind of mean the same thing. Next, they say if lines are parallel, then the alternate interior angles are congruent. All right, where do we have alternate interior angles? Here, we've got B and A. So we're going to say that A is equal to B, because that's how your book likes to do it. All right, now we can now say that angle A is congruent to angle C. Now, how do we know that? B is equal to C and B is equal to A. So if I substitute C into B right here, I'd get A equals C. So this is called substitution. Technically, it's not. It's called the transitive property or the law of syllogism. But again, your book kind of plays loose with some of our descriptions that we do. So we'll just call it substitution just so we don't have different answers in the book. All right. So we got substitution there. Next one. A perpendicular bisector. So a perpendicular bisector is a line segment that is, number one, perpendicular, because of the name, and it bisects another segment. So it cuts a segment into two congruent parts. So here we've got PM. It's a perpendicular bisector to AB. So since it's a perpendicular bisector, two things happen. A, it's perpendicular. B, it bisects, meaning it cuts it into two congruent parts. All right, so for this one, we want to prove that PA is congruent to PB. this distance here, which doesn't have a line, so let's just go ahead and make a little line there, is congruent to PB. This is the perpendicular bisector theorem is what we're trying to prove here. So we're trying to prove that those two segments are congruent. We always start off with what we're given. So this is our given. Now, because it's a perpendicular bisector, by the definition of that, something has to be perpendicular. Well, PM has to be perpendicular to AB. Here's another section where your book is going to play a little bit loose with this. Since they're perpendicular, we're going to say that these are both right angles. Okay, so we're going to say angle PMA and angle PMB are right angles. That's the definition of perpendicular. Perpendicular lines create right angles. So those two are right angles. Definition of a bisector. Well, bisector means that you're splitting it up into two congruent parts. So we can say, oh, we just proved that these are both 90. We can say that AM is congruent to MB by the definition of bisector. So AM is congruent to MB. Definition of bisector. Now our goal here is to prove that these two are congruent. Now look, we've got two triangles here. So if we can prove the triangles are congruent, then the corresponding parts of the triangles are congruent. So we're going to say that PM is congruent to itself by the reflexive property. That's the reflexive. So I've got an angle, right angle, side, right angle, side, right angle, side. We're going to have side angle, side on this one. So the only thing that we haven't done is proven that these two are congruent. We said they're right angles. Now we're going to just say that they're congruent. Again, another place that your book plays a little bit loose with proofs. That's okay. We'll just add in a little line here. And we'll say that all right angles are congruent. Okay, so here I've got the side, and the other angle. So we got side, angle, side over there. So now I can say the two triangles. So maybe I would say triangle APM is congruent to triangle BPM. And that's by side, angle, side. So since those two triangles are congruent, all the corresponding parts are now congruent. We proved these three parts. Well, this angle has to now be congruent to this angle, this side has to be congruent to this side, and this angle has to be congruent to this angle, because we just proved the triangles are congruent. So we're going to now say that PA is congruent to PB, because we just proved these two triangles are congruent. We're proving that this is now congruent to that. This is what your book says. Let's just call it CPCTC. Corresponding parts of congruent triangles are congruent. So it just means that if you got congruent triangles, any parts that correspond are congruent. And look what we have here. P and A is the first and second letter, and then P and B are the first and second letter. They're corresponding parts in our congruent statement, so they must be congruent. Backside. All right, so we're going to do some proofs with these, two-column proofs. So we've got our statements and our reasons. Now, before you do a proof, you want to be able to get a roadmap of how you're going to get there. So for this one, they say that C is the midpoint of BD. Okay, C is the midpoint of this segment. That means that this is congruent to this by the definition of midpoint. And it also says that AB is parallel to DE. So parallel lines usually tell me that angles are congruent, and indeed angle B here and angle D here are alternate interior angles. I could also use alternate interior angles on A and E, or I could use vertical angles here at angle ACB and DCE. So there I've got angle, side, angle. That proves the triangles are congruent. Now that I have a plan, I'm going to write down my stuff. First part, I'm going to write down the given. C is the midpoint of BD. And we know that AB is parallel to DE. Both of those are given. Now, in order to prove the triangle is congruent, I have to show three things are congruent. I have shown nothing congruent so far. So let's start stating our things that we wrote down. First thing that we wrote down was that CB and DC are congruent. So CB is congruent to DC. And we said the reason for that was that C was the midpoint. So that's the definition of a midpoint. Okay, so I got one thing proven. The next thing that we talked about was that angle B and angle D was congruent. And the reason we said for that is alternate interior angles are congruent. Now remember, you can only say that when the lines are parallel. So since we said the lines are parallel, it's okay to state this. If we didn't know the lines are parallel, we couldn't have stated that. So there's two things congruent. The third thing we said is going to be congruent is these vertical angles. So we're going to call this one angle ACB. And that's going to be congruent to angle DCE. We have to use three letters because if you just said C, we wouldn't know which of these angles you're talking about. And that's vertical angles are congruent. And lastly, now that we have three things proven congruent, we can say that these two triangles are congruent. And we said we were using angle, side, angle. So triangle ABD is now congruent to triangle EDC by angle, side, angle. And there's a two-column proof. Last one. So we've got statements and reasons. So this one says that K and P are right angles. That's why these two are there. GH is congruent to MN. GH, oh, that's not written on there. So GH is congruent to MN. And then GK is congruent to MP. Here's GK, here's MP. Well, now I've got angle, side, side. That spells donkey. So usually that doesn't prove congruence. But since this is a right angle, it does work because we've got the hypotenuse and the leg. I actually have in the given everything I need. I know that angle K and P are right angles. That's the first thing that I need for HL. I know that GH is congruent to MN. That was these two tick marks here. And I know that GK is congruent to MP. So I've got right angles. This one's the hypotenuse. This one's the leg. Those were all my given. And that is enough information since we've got right angles, hypotenuse, and leg. That's enough to prove these two triangles are congruent. So triangle GKH is congruent to triangle MPN. And the reason is hypotenuse leg. The end. Finished before the lights went off. Like a boss. All right, that's it. Math hard. See you.